this lecture, we will learn about statistical hypothesis, or commonly known as different statistical test, right? So before jumping into the actual procedure of testing and hypothesis, we should know what is the overall process and what is actually hypothesis and what are the different types of hypothesis. So basically, in many situations, what happens is that we cannot collect data from the entire population, right? So population are commonly very large, or in many cases they are infinite, and in such a case we cannot collect information from the entire population for a study. Instead, we select a sample. From that sample, whatever information is gathered, that can be utilized to draw a conclusion about the entire population. So in the process of testing of hypothesis, we make a statement or assumption about the characteristics of the population, commonly known as parameters, right? So characteristics of population are called parameters, and characteristics of a sample are called statistics. So the process of testing of hypothesis depends upon making a statement or assumption about the population parameters, and then we select a sample from that population. Based on the information from that sample, we calculate certain statistics. And what are statistics? Statistics are characteristics of the sample. Those statistics will help us to make a conclusion about the population parameter, right? So that is the workflow of testing of hypothesis. This process is called testing of hypothesis. Now, what is statistical hypothesis? Statistical hypothesis is an assumption about the characteristic of the population, right? So it's an assumption or a statement about the population under study, right? So for example, suppose you are interested in the average height of Indian male, right? So for this, if you want to do the actual calculation, you will have to measure the height of each and every Indian male, which is not feasible in many situations. So rather, we will select a sample from the population and we will measure the height of those sampled Indian male, and based on their average height, we will make a conclusion about the average height of the entire population of Indian male, right? So in such a case, we are making an assumption that the average height of Indian male is 168 centimeter. This is a statement about the entire population of Indian male, right? We are not talking about the sample, rather we are talking about the entire population of Indian male. So this is called a statistical hypothesis. Similarly, if we make an assumption about the average temperature of Guwahati, the city, during summer, and we are saying that the average temperature is 33 degrees centigrade, right? So in such a case, we are making an assumption about the entire population of days in summer, right? Temperature measured in summer, and therefore this is a statistical hypothesis, right? So if a hypothesis completely specifies the population, then it is called a simple. Otherwise, it is called a composite hypothesis. Now, to understand this statement, we will have to take help of mathematical notations. Like, let's say we are taking help of normal distribution, or let's say binomial distribution. So in case of binomial distribution, there are two parameters, n and p, right? N is the number of times the experiment was repeated. P is the probability of success. Now suppose our hypothesis about the population, and the population is a binomially distributed population, and we are making an assumption that n is equal to 10, right? That is the assumption about the population. Or let's say p or p is equal to half. That means the probability of success and failure is equal, right? Now when we make an assumption about like this, we are making assumption about only one parameter, only about p. We are not assuming anything, or we are not making any statement about the other parameter n. So this is not complete, right? We are not specifying the population completely. we are partially specifying or partially making assumption about the population. So in such a case, that kind of hypotheses are called composite hypothesis. But if your hypothesis is like that n is equal to 10 and p is equal to half, in this case we are specifying both the parameters, right? So this kind of statement or this kind of assumptions are called simple hypothesis, right? So a statistical hypothesis is a statement or assumption about the characteristics of the population, not the sample, right? So there are two types of statistical hypothesis. One is called null hypothesis and the other one is called alternative hypothesis. And these two are the most important thing that you should know. When you are going to do any real life study, you must include in your study, if you are going to do any kind of statistical test that we will be discussing later on in this video, then you must include a null hypothesis and an alternative hypothesis. A statistical test or a testing of hypothesis without null and alternative hypothesis is meaningless, right? So basically null hypothesis is the statement that we are trying to test whether that statement is true or false, right? So this is a definition of null hypothesis. A null hypothesis is a hypothesis which is tested for possible rejection under the assumption that it is true, right? So for example, in this case here, this is an example of null hypothesis, right? This is a statement that we are trying to prove whether it is true or false, right? If it is true, we will accept it. If it is false, we will reject it, right? So this is a statement that we are trying to prove whether it is true or false, right? So that is called a null hypothesis. And there is one key point about a null hypothesis. A null hypothesis is a statement of no difference. No difference, right? No difference means it must contain the equal sign, right? Or the word not. It is a very general rule that I follow while setting up a null hypothesis, is that it must contain a equal sign or the word not, right? Or the word no. No difference, right? This kind of statement are regarded as null hypothesis, and we denote it by H naught. H suffix 0 is the notation for null hypothesis, right? So any hypothesis or statement which is complementary to our null hypothesis is called an alternative hypothesis, right? So let's say I am stating an assumption or hypothesis that x is equal to 10, right? Now I am using the symbol equal, that means it is no difference, and that's why it is regarded as null hypothesis. Let's say x bar is 10, that average is 10, right? So a complementary statement to this particular assumption or null hypothesis will be called an alternative hypothesis, which is denoted by h1, right? So what is h1? H1 may be anything. H bar is not equal to 10. That is also a complementary statement, right? Someone can say no, x bar is greater than 10, right? That is also a complementary statement. And someone may say x bar is less than 10. That is also a complementary statement, right? So all these three are basically alternative hypotheses, and it is up to the researcher or the person who is conducting the study to choose between any one of these alternative hypotheses, right? So if you choose this type of alternative hypothesis where you are using not equal to sign, that means it can be either greater than 10 or less than 10, right? That means this particular alternative hypothesis is a combination of both of these two hypotheses, right? So this is called a two-tailed alternative, whereas these two are called one-tailed alternative, right? So depending upon your alternative, the test also get different names, right? So a test of two-tailed alternative will be called a two-tailed test. A test for one-tailed alternative will be called a one-tailed test, right? So in this topic, that means under null hypothesis and alternative, what are the things that you should remember is that null hypothesis must be a statement of no difference, right? You cannot say this statement or assumption that x bar is not equal to 10 in your null hypothesis. That will be a wrong, right? So you cannot use this assumption that x bar is greater than 10 in your null hypothesis, right? There are some situations when the question is test whether x bar is greater than 10. The question will say will be asked you to find out whether x bar is greater than 10. Though the question is asking you to test whether x bar is greater than 10, you should not include that statement as your null hypothesis. That will be your alternative hypothesis, right? So this is null hypothesis and alternative hypothesis. Another thing that you should know that H0, H1 are the symbols for this is null hypothesis, this is alternative hypothesis, right? So based on, now in this case, these statements that we make about the population parameters or characteristics can either be true or either be false, right? So your statement can either be true or false. And at the end of the test or the statistical methods that we will use or the formula that we will use will tell us whether we should accept the null hypothesis or reject the null hypothesis, right? So based on that, we have 4 different distinct situations, right? So over here we have the different types of decisions. That means we can either reject the null hypothesis or we can either accept the null hypothesis. Similarly, the actual situation may be the null hypothesis is actually true or the null hypothesis may be actually false, right? So what happens when the null hypothesis is actually true and you reject it, right? That's a kind of error, right? You are making a mistake. That statement that you made at the very beginning of your test was actually true, but when you applied the statistical test, the test says that you should reject that statement, right? So you are basically, your test is failing. Your test is asking you to disbelieve something that is actually true. So that kind of error is called type 1 error, right? This kind of mistake is named as type 1 error. Now when the hypothesis is true and you accepted it, right? So that's a correct decision. So this is good for any kind of study. Similarly, if the statement that you made at the beginning of your study was actually false and you rejected it, so you are disbelieving something which is actually not true, right? So that's a good decision. That is good for any kind of study. And the last situation is, it is actually false, but you accepted it, right? So you are believing something which is not correct, right? So that is also a type of mistake, and this kind of error or mistake is called type 2 error. So we have 2 different kind of errors while making conclusion about our null hypothesis. What are the different types of error? Type 1 error and type 2 error, right? So what is type 1 error? The error of rejecting H0 when it is actually true is called type 1 error, right? So similarly, the error of accepting H0 when it is actually false is called type 2 error, right? Now type 1 error is associated with a word called level of significance, which is very commonly used, and it is an integral part of any kind of statistical study, right? So any statistical test is incomplete without the concept of level of significance. Now what is level of significance? Level of significance is the probability of making type 1 error is denoted by alpha, and it is called level of significance, right? So what does level of significance mean? It is the probability of committing type 1 error That means it is the probability that you will be rejecting something true, right? So rejecting something true is very vital or very crucial for any study. That's why level of significance is also very crucial for any kind of study. That's why in statistical test or in this testing of hypothesis, we normally fix the level of significance before even conducting the study, right? So the common values for alpha are normally 5% or 1%, or even in some cases it is 10%. The higher the value of alpha, the weaker will be your conclusions. The lower the value of alpha, the you can say the conclusion that you will draw will be stronger, right? So what is 5% level of significance, or in some cases 95% level of confidence? So level of significance and level of confidence are complementary to each other. So if your level of significance is 5%, the literal meaning is 5 out of 100 times you are going to commit type 1 error. That means 5 out of 100 times you will be rejecting something true, right? So similarly 1% means 1 out of 100 times you will be committing type 1 error. The lesser the number of times you are going to commit type 1 error is better for you, right? So that's why lower the value of level of significance, your test is more appropriate. The complementary is, if your level of significance is 5%, your level of confidence will be 95%. Now what is the meaning of level of confidence? Level of confidence, right? So what is level of confidence? That I am 95% sure that my conclusions are correct, right? Similarly, if your level of significance is 1%, your level of confidence will be 99%, and it means that I am 99% sure about the conclusion that I am drawing about the population parameter based on this study, right? So that is type 1 error, type 2 error, and level of significance. So there is another term that is associated with any kind of statistical test, that is called degrees of freedom. Now, degrees of freedom is the amount of independence enjoyed by a dataset, right? Suppose you have, let me give a small example here to understand what is degrees of freedom, right? So suppose we have two values or two quantities A and B, right? So without imposing any kind of restriction, I am not giving you any kind of information about A and B. So it is unrestricted. In such a situation, you can take any value for A and any value for B. You have the full liberty, right? You have two quantity A and B, and I am asking you to choose any value for A and B. So you have full liberty. In such a case, the amount of liberty enjoyed by these two numbers is 2. But as soon as I impose a condition here, let's say the condition is A plus B must be equal to 10, right? As soon as a condition is imposed on these two quantities, the liberty is reduced. How? Because if you select the value 15 for A, the value of B is instantaneously decided by this condition, right? So value of B must be equal to 5. You no longer have the liberty to choose the value of B. So we imposed a constraint 1 or a condition 1, and there are two items, right, initially. So initially without this constraint, their liberty was 2. You were able to select both of them or two items. As soon as I impose a condition, you have the liberty to choose the value of only one quantity, right? That means 2 minus 1 equal to 1 numbers of freedom, right? Similarly, let us suppose we have three quantities A, B, and C, right? So now, without any kind of constraint or conditions imposed to this number, you have the liberty to choose all three numbers. You can randomly select any value. I can select 20 here, I can select 10 here, I can select 1000 here. I am not restricted to choose any number, right? So we have a freedom of 3, right? But as soon as I impose a condition that a plus b plus c must be equal to 100, right? So a condition is imposed here. Now what will happen? I have the liberty to choose the value of a, I have the liberty to choose the value of b. So I have selected 20 for a, 10 for b. But I no longer has the liberty to select the value of c. Why? Because their addition must be equal to 100 and the value of c will automatically decided as c equal to 70 because the remaining two added up to 30, right? And that total should be equal to 100. So I no longer have the liberty to select the value of c. So imposing one condition reduces one liberty. So what if I select or I impose another condition that a plus b minus c should be equal to 20, let's say, right? So if I impose another condition, in this case I will lose another liberty. The higher the number of conditions you will impose in your data set, the lesser will be the liberty enjoyed by that particular data set, right? The liberty is calculated by degrees of freedom. So suppose in a data set we have n items. Now we are trying to generalize it. So we have a data set of n items, right? And that data set is conditioned to k restrictions. So what will be the degrees of freedom or the liberty enjoyed by it? N minus k, right? So this is called degrees of freedom, which is very commonly used in statistical tests, right? So what are the different statistical tests that we are going to cover in this series or in this lecture? There are three different tests that we are going to cover. One is one sample t-test, which is used to test for single mean. One is independent sample t-test, which is used to test for difference of mean. And another one is called chi-square test, right? So one sample t-test, independent sample t-test and chi-square test. Right? Now the difference between these three are, this t-test as the name suggests will be same, right? So these two, this one sample t-test and independent sample t-test are for numbers, right? Or for numerical data. This chi-square test is for, as the name suggests, test for independence of attributes. What is attributes? Attributes are categorical data. So numerical data, if you are going to test for numerical data, we are going to use t-test. For categorical data, we are going to use chi-square test. There are a lot of other tests also, like z-test, which are very similar to t-test. The only difference is that when your number of observation n is less than or equal to 30, we call it as small sample, right? If your number of observation is less than or equal to 30, it is called as small sample. If it is observation is greater than 30, then we call it as large sample, right? So this t-test, both these t-tests are meant for small sample. If you are going to do a similar kind of test for large sample, then it is called z-test. The approach is same, the formulas are almost identical, right? So it is very minor difference between them, right? So there are some other tests also, like ANOVA, or like you can say we have non-parametric test also, but those are beyond the scope of this syllabus. So we will be sticking to these three tests, that means t-test, one sample t-test, independent sample t-test and chi-square test. So let's start with one sample t-test. Now what is the null hypothesis? So every test, whenever you conduct a statistical study or statistical test, you should follow some steps, right? There should be some kind of steps that should be followed. The first step is to set a null hypothesis. You always set the null hypothesis first, and if you want, you can set the alternative hypothesis also. but alternative hypotheses are not that necessary or mandatory. You can skip that part also, but you can include it also, right? So the first step is to setting out your null hypothesis. Then what kind of test you are going to do? Based on that, you have to write down the test statistic. The test statistics is nothing but a formula, right? It is nothing but a formula to calculate or to make a conclusion whether you should accept it or you should reject it, the null hypothesis, right? And finally, based on the values or the calculations, you will draw a conclusion, right? So all the three tests that we are going to do, we will follow the structure. We will set a null hypothesis, we will write down the formula, and then we will make a conclusion, right? So for one sample t-test, the null hypothesis is the sample mean x bar is not significantly different from the population mean mu. See, I have already stated while defining null hypothesis that null hypothesis is a statement of no difference. That's why we are assuming that there is not significant difference between the quantity x bar and mu. Now what is the word significant difference, right? So significant difference means the gap between the two quantity is not very wide with respect to the data, right? If the difference between these two are very wide, we will say that the difference is significant. If it is negligible, we will say that it is not statistically or not significantly different. So one sample t-test, the formula is t equal to x bar minus mu capital S by root over n. N is the number of observation, right? What is x bar? X bar is the sample mean, right? What is mu? Mu is the population mean. Population mean. This S is given by this formula. Actually S square is given by this formula. It is called sample mean square, right? So it is similar to standard deviation. Only thing is different is that we are dividing it by n minus 1 instead of n, right? And obviously n is number of observation. So when you put everything into this formula, we will get a value. That value is called calculated value of t statistic. That is called calculated value of t statistic. Remember, do not include the s at the end. It is not statistics. Statistics is the subject. Statistic is a characteristic of the sample, right? So calculated value of t statistic. Now how to draw the conclusion? If the modulus value, right, that means the positive value of this calculated t statistic is greater than the tabulated value of t, right? So we will have a table, right? This table refers to the different values of t statistic for different degrees of freedom and different levels of significance or alpha. Based on that table, we will make a conclusion. If the value we have calculated using this formula is greater than the tabulated value or the reference value, we will reject our null hypothesis and say that yes, they are significantly different, right? If the value is less than the tabulated value, we will accept our null hypothesis and say that okay, fine, they are not significantly different, right? So that is the process. Now this will be cleared if you go and explain the process via a example, right? So this example gives us the heights of 10 individuals, right? 10 individuals are chosen from a normal population and their heights are found to be 53, 63, 67, 68, 69, 70, 70, 71, 71, 66 inches, right? So these are the samples, the values that are given from the sample, right? The property of the sample. So what we are trying to find out, test whether the average height of the population is 66 inches. So here we are trying to find out whether mu is equal to 66. Now why mu? Mu is the population here. Mu is the population mean, right? And the question is asking you to find out whether the population average height is 66 inches. So basically it is asking whether mu is equal to 66 or not, right? So let's try to solve this. I will go step by step while solving this, and the calculation will be shown using a spreadsheet software for time saving, but you can do the same, or you can repeat the same process using a calculator also. So the first thing here is to write down the null hypothesis, right? So I am writing down the solution. Solution is this is a sample test and we are using one sample t test, right? The null hypothesis to be tested is H0 population mean mu is equal to 66. Now you can write this in words also, right? And the alternative hypothesis is H1 and the alternative is H1 mu is not equal to 66, right? So we have stated the null hypothesis and the alternative hypothesis. Then you write down the formula, right? The test statistic to test H0 is given by, what is the formula? T is equal to x bar minus mu capital S by root over n, right? So this is constructing your null hypothesis and alternative hypothesis. This is stating the formula. The next step is to calculate the different terms needed, right? So mu is already specified, that is 66. We need to find out the value of x bar and we need to find out the value of s square. As soon as I got or we get these two values, x bar and s square, we can replace the values here and we will get a value of t, right? So for calculation, let's go to a spreadsheet software, and here I have inputted the value. These are the values of x, right? Our x started from 53 up to 66. These are 10 values. So we need x bar. Now what is x bar? X bar is nothing but the arithmetic mean, right? So arithmetic mean can be calculated by adding this number divided by a number of observation. So let me find out the total, right? So what is the total? Total, I am adding, the sum is 668. And how many observations there are? You can see 10 observations, right? So what will be x bar? X bar will be equal to 668 divided by 10. So the value is 66.8, right? So our x bar is 66.8. x bar here, x bar equal to 668 divided by 10 is equal to 66.8, right? Now what is s square? The formula for s square is 1 by n minus 1 summation x minus x bar whole square. So for calculation of s square, we will need the difference between x, every x with their arithmetic mean. Then we will have to square it, right? And finally the sum should be divided by n minus 1, right? So let's first try to find out this value, that summation x minus x bar whole square, using this calculation. So here I will subtract this minus 66.8. That means I am subtracting the arithmetic from all of them, right? And I will click and drag. This will give me the difference for all of them, right? Then in this box I am going to find out the square of this value, right? That means minus 13.8 square, right? This give me 190.44. Now I can click and drag and it will give me the value. So this column over here will give me the x minus x bar whole square, right? This column over here, this 190.44 up to 0.64 is giving me x minus x bar whole square. So I need the total of this column. So I will add the sum, and the sum is 267.6, right? So summation x minus x bar whole square is equal to 267.6, right? 267.6. So what will be s square? It will be 1. How many n? N is 10 minus 1 into 267.6. That means 267.6 divided by 9, which is equal to 267.6 divided by 9, which is 29.73, right? I will write 29.73. So this is the value of s square. But in the formula, we need the value of s, right? S divided by root n. That means we need to take the square root. So s will be root over 29.73, which is equal to square root of 29.7. 29.73, and the value is 5.45. This 5.45. So we got the value of s, which is 5.45. We got the value of x bar, which is 66.8, right? So we can now find out the value of t. Now t is equal to, what is x bar? X bar is 66.8. What is mu? Mu in the null hypothesis was taken as it is taken as 66, right? So we will write 66 here. What is s? S is 5.45 divided by, what is root n? Root 10. So if you solve this, you will get the value of t, which is equal to 0.37, right? So we got the value of t as 0.37, and this is the calculated value of t. Now our task is to make a conclusion. So how to do conclusion? You will have to set the level of significance, or right, for this particular question, or before drawing any test, we will take 5% level of significance, right? Now 5% is the standard, right? For any test, the standard value is 5% level of significance. That means 95% confidence. So we will see the value of this t for 5% level of significance. So this is a website that I created using R programming, which will help you to find out the value of tabulated this test, right? Tabulated value of different test statistics. So we are right now using t-test. So this is the section where you will find tabulated value for t-test, right? And the standard value is 5%, which is set by default, and you will have to select degrees of freedom, which will give you the value or the required tabulated value over here in bold, right? So before finding out the tabulated value, you need to know what is the degrees of freedom, right? So how to find out degrees of freedom? In any test, in case of one sample t-test, the degrees of freedom is given by n minus 1, where n is the number of observation, because the formula, this formula or this test statistic follows t distribution with n minus 1 degrees of freedom, right? Now t distribution is beyond our scope, so that's why I cannot explain in here what is t distribution and what is n minus 1 degrees of freedom for t distribution. But this test statistic follow a certain kind of distribution known as t distribution with a degrees of freedom n minus 1. What is n? N is the number of observations, right? So that means here we have one restrictions, right? So n minus 1 degrees of freedom is the degrees of freedom for which you need the calculated value or tabulated value for t-test, right? So I will write down the conclusion, right? The tabulated value of t statistic for n minus 1 equal to 9, right? Here n is 10, 9 degrees of freedom at 5% level of significance is, so we need to find out tabulated value, and we will go back to here. We have 5% set already. We need to set the degrees of freedom. If you slide this to 9, right? So it will give you the tabulated value of t-test for 9 degrees of freedom is 2.2622, which is the required value. What is 2.2622? Is 2.2622. So that is tabulated value. Now what is calculated value? Calculated value is 0.37, which is obviously less than the tabulated value, right? So how we will write the conclusion? Since the modulus of t is less than the tabulated value, so we may accept the null hypothesis, right? So we may accept the null hypothesis. So see the use of the word may. So when you reject a null hypothesis, you don't say we reject the null hypothesis. We said we should reject the null hypothesis. When you accept the null hypothesis, we don't directly say we accept the null hypothesis. We say we may accept the null hypothesis. That is the way we write down conclusion in statistics, right? So this is a process of calculating one sample t-test, right? The next test is independent sample t-test, right? So independent sample t-test, similarly here also we have to decide the null hypothesis first. So here the null hypothesis is there is no significant difference between the two populations, right? So what happened in independent sample? In our previous example, we are given data related to only one sample, right? But independent sample is when you have two different samples. Let's say in the previous example, these 10 values are related to male, right? These are for male population, male sample, right? And we have another sample for female, right? We have a male sample, we have a female sample. So we can find out whether the average of male and average of female are significantly different or not. If you are interested in such kind of conclusions, then we use independent sample t-test, right? So we assume that the two different sample means or the two different populations means are not that significantly different, right? We are assuming that they are similar. And the formula to calculate it or the test statistic is T is equal to x1 bar. That means the mean of the first sample, mean of the second sample. This is combined root mean square. This is 1 by n1. n1 means the number of items in your first sample. n2 is number of items in your second sample. This test follows T distribution with n1 plus n2 minus 2 degrees of freedom. So this time when we are going to look into the table value, we will have to look for n1 plus n2 minus 2 degrees of freedom, right? So suppose in your first sample you have 10 observations. In your second sample you have 8 observations, right? So the degrees of freedom will be 10 plus 8 minus 2 equal to 16 degrees of freedom, for which you will have to refer the tabulated value, right? Now how to calculate this combined root mean square? You will have to use this formula, right? So just like the previous one where s square for one sample is 1 by n minus 1 summation x minus x bar whole square. Now this time we will have to calculate this 2 times separately for the two samples, and then we will combine it, divide it by n plus 1, n1 plus n2 minus 2, right? And the conclusion are same. If t is greater than the tabulated value, we reject the null hypothesis. If this will be n1 plus n2 minus 2 degrees of freedom, and otherwise we may accept the null hypothesis, right? So let's see an example. In this example, we are given two different samples, right? So two different protein supplements A and B were given to 5 persons and 8 persons respectively, right? And their gain in weight after 1 week were recorded. And I am interested in finding out whether the average gain increased by both the supplements are same or different, whether the average gain is significantly different or not, right? So if the average gain is not significantly different, that means if our null hypothesis is accepted, we can say that both the supplements are working in the same way. If it is significantly different, then you can say that no, one is better than the other in gaining weight, right? So we have two samples, right? Supplement A, supplement B. So let's get back and write down the procedure or the solution here. Solution. This is a case of independent sample t test, right? The null hypothesis to be tested is it's not the average gain in weight for both the supplements are not significantly different, right? That is our null hypothesis. So you can set an alternative hypothesis also, right? H1, they are significantly different. The test statistic to test H0 is t equal to x1 bar, or if you are not comfortable with this suffix 1 or 2, you can simply write x bar minus y bar as root over 1 by n1, or even if you are not comfortable with n1 and n2, you can use 1 by n plus 1 by m. It's completely fine. Now which follows t distribution, since we are using n and m, it will be n plus m minus 2. Now if you use this formula also, it is also valid and correct, right? It is not mandatory to use n1 n2 or x1 x2, right? This will make your calculation simple, right? Now what is n? N is the number of items in the first sample. M is the number of items associated with y, that means second sample, right? So we will calculate. Now what is S? S is equal to 1 by n plus m minus 2, right? Summation x minus x bar whole square plus y minus y bar whole square, right? So we will have a set of x, we will have a set of y, we will calculate the x bar, we will calculate the y bar, we will subtract them from the values of x, and we will square them just like the previous examples, right? Now let's get back to a spreadsheet software where we will enter the data and we will make the calculations, right? So these are the values. We have x and we have y. We have 5 items in x, we have 8 items in y, right? So first thing we will have to calculate x bar and y bar, right? So to calculate x bar and y bar, you need total, right? So total will be equal to this is 23 and the total of y is 49, right? So x bar is equal to 23 divided by 5. Similarly y bar will be equal to 49 divided by 8, right? So 6.125, that is the average of y. Now you need to find out x minus x bar. So x minus x bar, and we need to find out x minus x bar square, right? Similarly you need y minus y bar, and you need y minus y bar square, right? So what is x minus x bar? This is equal to 5 minus x bar is 4.6, right? So I will click and drag, which will do the calculation for the rest, and this will be equal to 0.4 square, right? These are the values. Similarly, what is y minus y bar? Y minus y bar equal to this y, that means 3, minus y bar is 6.125, right? So these are the values. This is not needed, and this one will be the square of these values, minus 3.125 square, which gives 9.76. And right now we need the total of this column and we need a total of this column, right? So total of this column will be 13.23 and total of this column will be 50.875. so this value over here 13.25 and 15.875 will be used in our formula, right? So let me go back to my calculations and write down here x bar is equal to I guess the x bar was 4.6. so x bar is 4.6, y bar is 6.125, right? Summation x minus x bar whole square is equal to 13.2. Summation y minus y bar whole square is equal to 50.875. and number of observation is x is 5, m is 8, right? So now s square is equal to 1 by n plus m minus 2 summation x minus x bar whole square plus summation y minus y bar whole square. This is equal to 1 by n is 5 plus 8 minus 2 and this is 13.2 plus 50.875, right? So this is equal to 13.2 plus 50.875 gives you 64 and this will give you 11, right? 1 upon 11 and 64.075 which is equal to 5.825, right? So this is the value of s square, but we need s, so s will be root over of 5.825 which is equal to square root of 5.825 is equal to 2.413. so this is the value of s. So finally we will calculate t, which is equal to x bar minus y bar as 1 by n 1 by m, right? Which is equal to, what is x bar? X bar is 4.6. What is y bar? 6.125. What is s? S is 2.413 root over 1 by 5 1 by 8, because n is 5, m is 8. Now this will give you, so 4.6 minus 6.125 gives us minus 1.525, and the denominator, if I simplify, it gives me 1.3756, and at the end the value is minus 1.109, right? 1.109. So this is the calculated value of the t statistic. Now we have to compare it with the tabulated value, right? So I will write the tabulated value for t statistic for how many degrees of freedom? 5 plus 8 minus 2 equal to 11 degrees of freedom. Degrees of freedom in short written as df at 5% level of significance is, now what is the value? We will go back to this. Now this side gets disconnected if you don't use for a long period, so just refresh. And here we will go to the section of t-test, and the degrees of freedom is 11, right? So for 11 degrees of freedom it is 2.201. 2.201 is 2.201. Now our calculated value is 1.109, right, which is obviously less than. So since modulus of t is less than the tabulated value, so we may accept our null hypothesis. That means we can accept that both the supplements, the performance of both the supplements are same. The average increase or gain in weight are same for both the supplement A and supplement B. So this is an example of t-test when you have two samples, right? Independent sample t-test. So the next test is chi-square test. Now as I have already said, chi-square test is for not numerical data. It is rather than used for attributes, right? So what is attributes? Attributes is categorical data. When you have, let's say for example, genders, when you have, let's say for example, some kind of data related to qualities, yes or no, accept or reject kind of situation, then we use chi-square test. And it is used to find out whether two attributes A and B are independent or not, whether there is a relationship. So in case of correlation, if you remember, the simple correlation was used to find out whether there is a relationship between two number series, right? Two variables which results in numbers. Chi-square is used to find out whether there is a relationship between two characters, right? Like whether there is a relationship between educational qualification and gender. Both of them are categorical variables, right? Similarly, whether there is a relationship between gender and their preference for a particular food or not. So in such a case, we use chi-square test, right? Now what is the formula? This is the symbol of chi-square. This is chi-square. And chi-square is, it looks similar to x, but one is curve, one is straight line. The formula is OI square minus by EI minus n, where OI are called observed frequencies and EI are called expected frequencies. Observed frequencies will be those frequencies which are given in the question paper or the question. EI is that frequency that you will calculate, right? So the first task here is to set the null hypothesis. The next task is to prepare a table. The table is called contingency table, right? You will have to prepare a table called contingency table from the given data or from the observed frequency. From that contingency table, we will create or we will calculate the expected frequencies, right? Once the expected and observed frequencies are calculated, we will place the values in this formula, and if this value is greater than the tabulated value, we reject the null hypothesis. If the value are less than the tabulated value, then we may accept the null hypothesis, right? So this is the formula. Now in this case, the degrees of freedom is number of rows minus 1, number of column minus 1. Now in the contingency table, you will have certain number of rows, certain number of columns, right? So the degrees of freedom will be decided by the number of rows and number of columns here, right? So let's take an example. In this example, we are given that there is a sample of 500 students, right? So out of these 500 students, 300 are boys, and out of these 300 boys, 170 prefer tea and the remaining prefer coffee. Similarly, out of those 200 girls, 90 prefer tea and the remaining prefer coffee, right? So you are to find out whether the preference of drink is related to their gender or not. So we are trying to find out whether, in simple word, we are trying to establish whether there is a correlation between drink and their gender. We cannot say it as a correlation or relationship. In simple word, we are trying to find out whether there is a relationship between choice of drink and gender, right? So let me go back and formulate the solution. So at first we will write down the null hypothesis, right? Here the null hypothesis to be tested is H0 choice of drink and their gender are independent. Or you can also write like choice of drink has no relationship with their gender. They will mean the same, right? The alternative will be choice of drink is, or you can say choice of drink is dependent on their gender. That is our alternative, right? For calculation, we construct a contingency table, right? So what will be the contingency table? So there will be gender, right? Boy, girl, right? There will be some who prefer tea, some coffee, right? The total number of boys is 300. The total number of girls is 200, right? So if I make a table, if I divide, this will be called a contingency table, right? So this will give you total. Now in the question, it is given that out of these 300 boys, 170 prefer tea, right? So 170 prefer tea. So what is the remaining number? Remaining number is 130, which prefer coffee. And it is given that out of these 200 girls, 90 prefers tea, right? 90 prefers tea. So what is the remaining number? 110 prefers coffee, right? Let me check whether I am correct or not. Okay, so 590 take tea, right? Okay, so what is the total number of person who is taking tea? 170 plus 90, so it will be 260. What is the total number of students taking coffee? It will be 240. And this box over here will give you the grand total. That means the sample size. And we have 500. The sample size is 500. So this table here, we have two categories in the row, two categories in the column, right? Two categories of gender, 2 categories of your drink, right? So that's why it is called a 2 by 2 contingency table, right? Suppose apart from tea and coffee, we have another category over here called, let's say, soft drink, right? In such a case, we have 3 categories in the rows, 2 categories in the column. So it will be 3 by 2 contingency table. So based on the number of rows and number of columns, the name of your contingency table will differ. So this is a 2 by 2 contingency table. So this is the data given in your question. Now these figures, this 170, 90, 130 and 110 are observed in real life, right? So these are called observed frequencies, right? So we will denote them by some numbers. So this one will be the first observed, this will be the second observed, this will be the third observed, and this will be the fourth observed, right? So that means O1 is 170, O2 is 90, O3 is 130, and O4, that means observed frequency number 4, is 110. Right? The next task is to find out the expected frequencies, right? So we will find expected 1, expected 2, expected 3 and expected 4. Now how to find out the expected frequencies? Now expected 1 will be related to this column, right? Since observed 1 is in this column, expected 1 will also be in this column. So we will get expected 1, expected 2, expected 3 and expected 4. Now the formula to calculate the expected frequency is row total into column total divided by grand total. So remember this, expected frequency is equal to row total, right? Row total into column total divided by grand total. Grand total. So if you are going to calculate E1, that is in this box, right? Now E1 lies in your first column and first row. So the total of first column is 300, total of first row is 260 and grand total is 500. So for E1 the calculated value will be 260 into 300 divided by 500, right? So similarly for E2, that means the second expected frequency, E2 lies in the second column, right? And in the first row. So the total of the second column is 200, total of the first row is 260. So it will be 200 into 260 divided by 500. This divided by 500 will be constant, right? E3 lies in your second row and first column, right? So first column the total is 300 and total of the second row is 240. So it will be 240 into 300 divided by 500. And the last value E4 lies in your second column and second row. Total of second column is 200, total of second row is 240. So 240 into 200 divided by 500, right? So what are the values? If I simplify this, this will be equal to so the on simplification we get these values of the expected. E1 is 156, E2 is 104, E3 is 144 and E4 is 96. So these are the observed value 170, 90, 130, 110. These are the expected value, right? So now that we have observed and expected, so we can go to the next step. The next step is calculating chi-square by the formula summation OI square by EI minus N. Now what is N? N is this grand total, right? So in our case, N will be 500 and we need EI square by EI, OI square by EI, right? So I will calculate this over here. Sorry for being so messy. I will try to calculate the values of the ratio over here. So I will calculate OI square by EI. Now OI square means 170 square, EI means 156, right? Similarly, OI means 90 square by 104, 130 square by 144, and last one is 110 square by 96, right? So that the value that I got after simplification are 185.26, 77.88, 117.36 and 126.04, right? So we need a total of this, right? For this we need a total of 185, and the sum of OI square by EI is equal to, so the value is 506.54, right? So the total of OI. So what will be the chi-square? Chi-square will be 506.54 minus N is 500, right? So the ultimate value is 6.54. So the calculated value of chi-square is 6.54, right? Now this is a 2 by 2 contingency table. That means we have 2 rows and 2 columns. And I said that the degrees of freedom in case of chi-square is number of rows minus 1 into number of column minus 1. So this will be 2 minus 1 into 2 minus 1, which is 1 into 1, which is 1, right? So the degrees of freedom in our example is 1. Suppose you have 3 columns and 2 rows. You have 2 rows and 3 columns. In that case, the degrees of freedom will be 2 minus 1, 3 minus 1 equal to 2, right? So based on number of columns and number of rows, you can decide the degrees of freedom. So in our case, the degrees of freedom in 1. Now we have find out the calculated value. Next step is obviously to find out the tabulated value. The tabulated value of chi-square for 2 minus 1 into 2 minus 1 equal to 1 degrees of freedom at 5% level of significance is, so we will get back to that website. Now you can refer to textbooks also. All major statistical textbooks includes these standard tables. Now if you don't have a table or a textbook, that's why I created this website, so that it is helpful or we can find out the value on the go, right? So for chi-square, you just need the degrees of freedom. So we have 5% level already set. Our degrees of freedom is 1, which is also default in many cases. So the tabulated value is 3.8415, right? 3.8415. So the value is 3.8415. Now what is the calculated value of chi-square? The calculated value is 6.54, which is greater than our tabulated value, right? Since the calculated value of chi-square is greater than the tabulated value, therefore the null hypothesis should be rejected. We should reject the null hypothesis, right? This is how we conclude or we calculate chi-square test, right? So this was our last example related to chi-square. So we have learned about three different types of tests that is commonly used in statistics. One is one sample t-test, one is independent sample t-test, and one is chi-square test, right? So that's all about statistical test and statistical hypothesis, how we can test hypothesis. There are different tests also that you can learn, and if time permits we will discuss them in the later time. So now we have covered the basic test, right? So that's all for this one. See you in the next one.